Hello friends, welcome back. Hearty welcome to you. In this session, let's have a look at properties of the limits. So just before going there, let's try to understand that suppose there are two functions f and g, both are mapping from a subset of real numbers to again to real numbers. E is a subset of R and f is from E to R and G is E to R, and E intersection A minus R, A plus R other than A is phi. What is the meaning of that? The meaning of that is on E we don't have any breaks in the graph. On E we don't have any, that means you have clear delta neighborhood where the function is satisfied, and we have taken A value which belongs to the R. In that case, suppose we know that if limit of f of x extends to a is L and the limit of gx extends to a is M, then we can see here limit of f plus g of x is nothing but equal to, can I say another way, is this is nothing but equal to limit of, maybe the one which should be written here is limit extends to a f of x plus limit extends to a g of x, which is nothing but equal to L plus M. So you can see that the limit of sum is nothing but equal to sum of limits. Similarly, the difference of limit is nothing, the limit of difference is nothing but the difference of limit. Similarly, here you can write in the same lines limit extends to a f of x minus limit extends to a g of x. Similarly, you can see that limit of products is nothing but equal to product of limits, that is nothing but equal to limit extends to a f of x into limit extends to a g of x. Similarly, you can do it for quotient also. You can write down limit of quotient is nothing but quotient of limits. That means it is nothing but equal to limit extends to a f of x divided by limit extends to a g of x. So you can see very clearly these are very simple. Limit of sums is equal to sum of limits. Difference of limits equal to limit of difference equal to difference of limits. Limit of products, two functions, when we say product means function of two products or more, is nothing but individual limit product. Similarly, the quotient, limit of quotients is nothing but quotient of limits. So another thing which is interesting is if p is a polynomial in x of the form a0 plus a1x plus a2x square till ak x to the power of k, where k greater than or equal to 1, then as x tends to a, limit of p of x is nothing but equal to p of a. So let us do some simple examples on this to understand properties. Suppose I have an example like this. Find the limit of x plus 3 into x plus 2 as x tends to 1. So by these properties, what I can do, I can separate them and say limit x tends to 1 x plus 3, that we have to multiply with limit x tends to 1 x plus 2. So these both are equal. Either you do this way or this way. This is nothing but limit of products. This is nothing but product of limits. So if I do that, I will have x tends to 1, so 1 plus 3 equal to 4. into here 1 plus 2 equal to 12. Now suppose you directly substitute here, taking this as one function, you will see that limit x tends to 1, that is nothing but equal to 1 plus 3. So that's nothing but equal to, can I say straightforward, I can say one plus 3 into 1 plus 2, that is nothing but equal to 4 into 3, that's equal to 12. So we can see that whenever we can leverage these properties and do the problems easily. All these properties, whatever we have, you can try addition, subtraction, multiplication, division. So with this background, in the next exercise we'll start problems where we solve the limits by using direct substitution whenever we can leverage these properties and solve the problems. So see you in the next session where we will solve limits by using direct substitution and after that factorization.